All right, so I want to take a look through a little bit of the OpenStack that's set up at Carleton today. And so we'll see how we can take a little bit of a look through it here and kind of explore how it's being used for courses and also how it's being used for other projects. And so first of all, to get started, just a little bit of context, I'm just going to go SCS OpenStack, and we'll just take a look at what the School Computer Sciences page on this is. And so it describes OpenStack as like an interface for cloud computing. And so this is like an interesting term because if you've had to use it in a course before, you go to a website, you make some changes, you follow some instructions, and you do stuff for it. And we also hear like this term cloud quite often, but like maybe the way that we hear it in industry is quite a lot different than how we hear it when we're learning it in a course, where it's like, oh, you have to use a cloud to do something. So we'll talk a little bit about that as well and what it means in this context. And so it also specifies that we're going to be able to easily launch and maintain instances, which instances mean virtual servers. And I mean, virtual servers, we can also think of stuff like VirtualBox or VMware that is used to host VMs on our computer, virtual machines on our computer. And so it tells us that with the School Computer Science OpenStack, we'll be able to run our own instances. So, okay, cool. We got some terminology here. Virtualization is like one of the terms that's used quite a lot here. And so this is like the way that it allows you to virtually pretend that an operating system is running on some hardware that's not actually direct computer hardware. It's running through something else. More specifically, it's running through a hypervisor. And so a little bit of a breakdown about the technology or the terminology here, but we don't need to focus too much on that. We'll be mostly working through some examples here. So it does give us a link right here for the OpenStack. And if I open it up, we'll see that it does load for me. And I am logged in. You'll get to like a login screen that you have to go through. But one thing I want to specify here is that it also tells us to log in through Carleton's VPN. And the reason for this is that OpenStack itself isn't open to the internet. And so the reason for this is really nice to have a security layer through a VPN, which stands for Virtual Private Network, where you have to connect to that first before being able to connect to like the internal servers. And so instead of making sure that OpenStack is perfectly secure to be open to the internet, instead you could just make sure that people log in through a VPN first and then can access things. And so I followed the instructions here. I have the VPN running on my computer, and actually, let me just change over the screen a little bit. And now that it's running, I'm able to access the OpenStack page. So it specifies that the OpenStack is used for coursework, is for faculty and research projects and honors projects, and it's running school infrastructure and all this kind of stuff. But let's start by taking a look at some of the screen as you log in. Now, I'm using the Carleton Computer Science Society view into things. However, I have access to a few different ones that I've been playing around with. And so I did a hackathon a few years ago, and we got some resources from that. We have the Carleton Web Dev Club. I was doing some work with Connor Hillen, and so we have our the one that we have there. I think we were hosting like Jupyter Lab on some of the machines. I had like I think I was doing some 1405 tutorial writing, and I needed a project to be able to set up some instances. And so right on this screen, let's take a look through what we can see here. Let me make it super big so that we can see what all is covered in the overview. Now, this view is kind of cool because it tells me what I have access to on the OpenStack. Now, OpenStack it's a weird thing when we say it's like a layer on top of the servers, and it's a user interface to interact with all of it. And the way that it sort of sits there, it's a little bit different from the computers that are actually underneath it. And so, for example, it will tell me right here that I have 8 instances I'm allowed to use. That doesn't necessarily mean I can use 8 computers. It means that I can use 8 virtual machines on OpenStack. And now these virtual machines might be different sizes. Maybe one of them is like super nice and small. It doesn't have that much compute power, and it doesn't have that much RAM. But on the other hand, maybe some of them are really large, where it has a lot of compute, a lot of RAM, or maybe it's a little bit of both, depending on the needs. So we can also see right here how many vCPUs we have. Now, these numbers themselves, 106 vCPUs doesn't mean so much. You kind of have to get used to what it means for the products you're working on. So for example, if you're hosting a small web server to just give you your index.html page for maybe like 2406, that's going to be very different than how many vCPUs you'd want if you have to do password cracking in one of the security courses. And similarly with RAM, it depends on the types of products that you'd be using. Now, there are some cool ideas here where just because it says I have 106 vCPUs does not necessarily mean that my that it's actually being shared like that on the hardware itself. And so what I mean is, if a virtual CPU maps to a computer CPU, or more specifically a computer hardware thread, let's say I have a CPU and it has 16 threads, then technically that would mean that I can only have 16 threads here. Well, in that case, what you can actually sort of do is break it down into virtual CPUs. And so it's like each of those 16, we actually are going to call them 4 CPUs each. And so now I have 64 instead of 16. And it means that you get less time per second on each of them. But you can split it up a lot more. And this is great for the case that the School Computer Science OpenStack is doing, where it needs a ton of virtual CPUs for a ton of students. And we'll take a little bit of a look at how those numbers actually map out. And so it's a bit weird to think about this, where it's like not mapping properly. Like 128 here might not actually mean 128 hardware vCPUs. But one of the really cool benefits of this is that it means that when you're using these virtual CPUs, if nobody else is using that computer at the same time, they're not running their web server, they're not doing their tests, whatever, then you actually get a lot more power allocated to yourself. And so maybe how it's allocated, you actually only be getting like 1/16 of a CPU thread per second, but because nobody else is using it, now you get the whole CPU thread per second. And so that's kind of nifty. RAM is a bit harder to share like this, because with vCPUs, like let's say everybody who was using their stuff, you just say, okay, you only get a 1/32 of a second, or you only get 1/100th of a second worth of CPU time, and then everybody can kind of make use of that, the resources that are being strained. But on the other hand, RAM is a bit different, because if I say that my computer has, let's say a massive server has 512 gigabytes of RAM, and I have 10 people using it, well, I have to be pretty strict in saying that they could only use 100. Or sorry, one second, my music is talking to me and I can't talk and listen to me. Okay, all right. So 512 gigabytes, and we split it down 10 people, that would be like 51.2 gigabytes. If someone goes over that, or if everybody's at that and tries to go over, then we're just out of RAM. You can't store more information than is right there. And so over provisioning RAM is harder. Anyways, and we also have volumes. These are like how we can store more data than a virtual machine might give us access to. So we would connect a volume to our virtual machine. We also have some ideas of floating IPs, networks, and all this kind of stuff. Really, in courses, the only thing here that I've made use of is floating IPs, so that I can access my virtual machine from the internet, and security groups, so that I can say which ports are allowed within the virtual machine. Okay, so now before we go look at our instances, what I want to kind of do is actually show us a little bit of the admin behind OpenStack. And so I've been working on some stuff with OpenStack for quite a while, and this has been like projects with the Computer Science Society. This has been my own experimentation. This has been running some meetups for people who are using the School Computer Science OpenStack. So those are on YouTube somewhere else. But I've gotten admin access to the OpenStack. And it's very much on like a policy of like, I get to kind of see behind the scenes on some stuff, but I don't touch anything that's going to break anything. But one of the really cool things I'm able to do is get like a bit of an overview on the OpenStack. Okay, well, maybe that's not the one I'm looking for. I'm looking for hypervisors. Okay, so we've been talking up until this point about how me as a single person uses a School Computer Science OpenStack. But on the other hand, we can look at it from the perspective of, okay, we walk into this room in Hertzberg. It's on the 5th floor with a lot of the other professor offices. We walk into this room and we just hear a whole bunch of computers blazing, right? Like the fans are going, it's super hot in there. You got network cables running all over the place. there's like server racks of just like 10 servers of the look the exact same, and then another server rack with servers that look a little bit different, and then another server rack that just has all the network cables going into it. And so in this room, this is where we can start thinking about like, okay, there are actually computers here. When I run a virtual machine on OpenStack, I don't think at all about which computer in that room it's running on. And so that's one of the really cool things about like the abstraction. OpenStack, this user interface lets me think in terms of, I want to run a virtual machine with this many resources. And then it's OpenStack's job to say, okay, I'm going to take that request that you gave me, and I'm going to put it on this machine because I know that there's this much space available. But we can see some really cool stuff here. We can see that across all of the computers that are part of this OpenStack cluster at Carleton. I don't know if there's like another word for, like, maybe they call it OpenStack fleet, or like data center, or like a lot of these terms where you have all these computers working together and one piece of software that's like managing all of it. So we can see that there are 1,184 virtual CPUs across all of them. And how this actually maps is, so I'm not 100% sure if it means that there are 1,864 actual cores within that room that are part of this fleet, or if it means that there are actually like half that many, and we're saying, okay, just double it, and we're going to pretend that's the real number. However, as I was mentioning, right now we can see that all of the virtual machines that are on all of these different servers are currently using 1,120 of the virtual CPUs. But this is so right now it's actually super low because it's during the summer. During a school year, you'll see this number go much closer to 1864, and often you see it probably closer to like 2,500, if I had to guess. And that's the overscheduling that I was talking about. And so with overscheduling, I mean giving people more than they're asking for right now, but relying on the fact that not everybody's using that at the same time. So we can see that's how much that's how many vCPUs there are. We can see that there's this much memory inside of the all of the servers, and we can also see that there's this much disk space available. And so so a few interesting things, a little bit of humble brag here. No, it's not even my humble brag, but like 117 terabytes, that's quite a lot of information, quite a lot of storage space. One of my buddies, he has like his own server set up at home, and he has like, I think like 250 terabytes of storage. And then, I mean, you can go to data centers and find significantly more. The most I've seen in one server was like a whole bunch of special hard drives that are designed for just storing a ton of stuff. And that was about like 1 petabyte. So that's like 1,024 terabytes. And so anyways, quite a lot of space. Whenever you boot up a VM inside of the OpenStack, you'll only get a small portion of space, like normally 8 or 16 gigabytes. And then you can get a volume that's like 100 gigabytes or 200 gigabytes or whatever you need. So you can make like special requests for that. So these are the numbers. These are the aggregate numbers of everything that is when you add it all up. But let's take a look at some of these actual machines. And so I want to look down at these stack ones here. And so these are all the default ones that are being used for students, projects and stuff like that. And then as we go up, we can see that different labs at Carleton. So Chorus has a few different servers here in this room. The graphics lab has one here. If we go down, we probably find some for, okay, oh yeah, we got a whole bunch of GPU servers as well. So these are, again, and actually just a little bit of context about what a server is. If you think of like a desktop computer, these are very, very similar to a desktop computer with like the size of them. However, their form is a little bit different so that you can put them in the racks. And so really there's not that many differences between a desktop computer and one of these servers, other than the fact that like the CPU and these servers are very different than desktop computers, and like the amount of RAM you have and all that kind of stuff is different. But you'd see a very visual difference between Stack 26, which is, if we take a look up here, okay, vCPUs and RAM. Okay, so I want to look at these two columns. So Stack 26 has 64 cores on its, there's 64 cores or 64 threads, one or the other, on its actual computer machine. And then it has 500 gigabytes of space free. Of RAM, 500 gigabytes of RAM. And then it also has 3.4 terabytes of storage. So what that tells us is, so 3.4 is not that big. Like I have a disk in one of my servers that's like 8 terabytes of storage. And so this is not a storage server. It's not designed to be a storage server. It's designed to be a compute server. It has a ton of, a pretty high amount of compute power, and it has 500 gigabytes of RAM. We can see some of the other stack ones here have like 750 gigabytes of RAM. So it's pretty cool to kind of see like what these machines are built of. So I would imagine this machine is probably like, it's like this tall, and then it goes like back, and it's like one of like the really flat pizza kind of servers kind of thing. But it's only really that tall. But then on the other hand, we have like this stack GPU right here. This one, it has significantly less, 4 times less CPU power. Maybe running like a Ryzen chip or something like that. Whether that's CPU cores or threads, whatever. And then it has not that much RAM as well, like a good amount of RAM, but it's clearly a different purpose than like 754 gigabytes. But it will have a GPU inside of it, or at least one GPU, probably several GPUs inside of it, to do a whole bunch of processing with that capacity. Then we can also probably find a server on here that has like a ton of terabytes. So, okay, actually, can I sort by? Yeah, okay, so right here we have a few. Okay, so it looks like 6.9 terabytes is like the largest storage in this cluster. Maybe like there's other storages somewhere else. Normally what you might find is one server whose only job is to have a ton of hard drives. And so that would probably be like your 100 terabyte server. Okay, anyways, we walked through servers quite a lot here. Now let's take a quick look at, so again, this is like the hardware level. This is the computers in the room in Hertzberg. Let's take a look at the mid-level of this, of how we like sort of like compartmentalize them and figure out how we compare them and contrast them a little bit. And so this is like the host aggregates. I don't know exactly what this means, but what I can see here is if like we have a name called compute, and compute contains all of the stack computers that we saw from before. We also have one called GPU, compute GPU, and this is all the GPU ones, and then maybe different names for different ones that are in different labs. And so actually one here that I quite like is we have the compute redundant power, and we have several like a lot of different machines that are on that. The reason that I find this helpful is because every time that this room inside of Hertzberg takes up too much power and then trips the power, and then all the servers go down, these are the servers that won't go down for a bit. And so I want to make sure that if I have stuff connecting to the internet, all of my tasks are able to keep running and say, oh, everything else around me failed. Okay, I need to be the one to run this task now. And so in a later video, I want to walk through how this, the CCSS, like the Computer Science Society, is using some of this for products like discretemath.ca and some other stuff. Okay, so we have all these different groups. We can say, if I want to make a VM, if I want to make an instance, if I want to run something that a course is telling me, I can say I want a virtual machine on compute. And when I say I want it on compute, it can go on any of these different machines. And remember, each one of these different machines is a physical, like almost desktop-like computer inside of this room in Hertzberg. And I don't need to think about this at all. When I've made an instance, I've never thought about this. I've never been like, which one does it? Well, actually, I guess in the case where I'm like, oh, I want it to be on redundant power, so that if the power goes out, this is still fine. That's the case. Okay, let's see if I can quickly hop back over to my, okay, let's go to instances actually. So this is the Computer Science Society's instances that are running. Let's see if I can quickly go through like the create instance. Hello, is my thing too big? Okay, well, okay, launch instance right there. Let's see, can I go to Hacking 1000? I feel like I probably don't have much running on here right now. Let's see. Cool. Okay, awesome. So if I were to click launch instance here, again, let's think through the terms of high-level abstractions. We're using a user interface to create something like a virtual machine. I'd put whatever inside of here. I'd say I want a certain amount of them. Okay, I got a lot of virtual machines. Awesome. And when I go to flavor, I can say, oh, I want to use 2 virtual CPUs. I want to use 8 gigabytes of RAM, and it's going to have this much disk space. Okay, awesome. So when I go back to details, now it's going to say, wait, is it going to give me the numbers somewhere? That'd be cool if it could say like, okay, maybe not. I was hoping it would show somewhere like how many resources it's going to use. But as I've done this, as I've said, okay, I need this many resources and I need 9 of them. Then as soon as I say launch instance, which well, I guess I could kind of do. It'd be kind of fun to just see them all boot up. And then, but the thing is, I'd have to go shut them down and quickly. Okay, we'll do like 2 of them. Okay, so what do we need? We need an image to run on it. So we got lots of images here. Ubuntu Live Server. Is that what I want? I think, is it a snapshot? I don't know if these are what I'm looking for. Okay, let's do image. Okay, whatever. I'll just use this one. It doesn't need to be super fancy. Okay, so, oh heck, let's turn it up. Let's do a little bit of work here. Okay, so I've just clicked launch instance on 10 virtual machines. So now it's telling me that it's going to start doing the process of setting stuff up. And without me having to say which server I want it to run on inside the room in Hertzberg, OpenStack is going ahead and doing all of this work for me. And the cool thing is it takes time to do this work. And so at first it got the request. It said, okay, the state that you want is to have 10 new virtual machines set up. And each of them are going to require 8 gigabytes of RAM and 2 virtual CPUs and 32 gigabytes disk. Well, it's not exactly sure right away where to put them. It has to look all the other computers, how much space is available. Is stuff going well? Is that all good? Okay, so it looked like they're all doing pretty well. And do I get to see somewhere where it is running? Instances. Okay, well, actually, no, I guess here, actually, okay, perfect. Okay, maybe if I just open a few of these up in a new tab. Okay. Oh, awesome. So right here, it actually shows me as I went into this one that I'm running on stack 18. Can I increase size a little bit? Okay, cool. So this is running on stack 18. Let's look at what the next one is doing. Stack 24. So it's running on another computer inside of there. This one's stack 20. This one's stack 26. And so each one of these is running on a different computer inside of OpenStack. And I mean, I don't remember what the number was before, but if we go back to admin and compute and hypervisors, then it's like 1,140. Maybe that number is different. It should be different. Wait, let's see how easy I can delete all of the instances. And then if I can go again, we can actually see, delete. Okay, perfect. Let me just make sure I actually delete the ones that I intend on deleting. And so, similar to me having set up each one of these with just an ask to OpenStack to create all of them, a deletion will be the same. It will take all of these. It will send out the command to all of these different machines. Say stop running this virtual machine. You're getting rid of all the data that's on it. Okay. So that's all done. So we were at 1,140 on the entire cluster before. Oh, perfect. And so now we're down to 1,122. Memory usage is the same just because we're talking about going between 100 gigabytes of memory to be able to see the difference in the significant digits, and we're not using that much memory. Storage probably the same. Oh, storage is a little bit different. Cool. So let's take just another look at the CCSS and how it is using its instances. And so this is what I just want to end off on, and hopefully this will give us a little bit of context as to what's going on with different use cases. And so right here we have quite a few servers. Let's see if I can make this well sized. I think that's pretty okay. So let's go here. So a few things to note about how the OpenStack infrastructure is being used in our case. We can see that just looking at the flavors first. This is what I would normally do when just checking out stuff is, well, actually, I guess I would look at the names. The names give you context as to what's going on. So I have stuff called Nomad Server 321, and then Nomad Client 321, and then something called Bastion. There's a backup of something. I don't remember what this is. I know what all of these are, though. And so, yeah, I want to cover this in a later video because there's some pretty cool ideas behind how stuff is being run on these machines themselves, or rather inside the virtual machine. But we care about outside the virtual machine. We care about saying, I want to throw in a virtual machine that's this big at a computer. All right, so right here, we can see the flavors. We have some that are 8 gigabytes of RAM, 64 gigabytes of disk, 2 virtual CPUs. And then on the other hand, we see some that are 64 gigabytes of RAM, 128 gigabytes of disk, 32 virtual CPUs. And so these are like obviously quite a lot larger, quite a lot more powerful. And in our case, we want to have some powerful computers that can run a lot of tasks if we have different services that need to be set up, or anything that might be like long time, like running for quite a while, or if we're doing like tests or anything like that. And so that's why when I was talking with Andrew Pullen, I asked that we could get a flavor that was like large like this. And then on the other hand, we have these virtual machines, and their jobs are very static. They'll do the same thing with the same amount of space, and their jobs won't grow any larger than they are at the start. And so it doesn't need to be super powerful. Now, on the other hand, like as I was talking about with examples before, maybe I go and do a web development course. So I need something that's like super small flavor like this. It doesn't need to do a whole lot. Maybe I'm doing databases again. Probably only 1 virtual CPU is needed. If I'm doing okay, there's a cool course. I hope it's still offered. I don't know for certain. It's like on parallel programming and this was not distributed. It's parallel programming and multiprocessor stuff, and that is super cool stuff because it allows you to say either I have something that has 32 virtual CPUs and I'm going to do algorithms on it that require all 32 of those to work as fast as possible, or I mean, if I scaled up to 64 vCPUs, I would be able to run the algorithm even faster, or 128 vCPUs. Oh my gosh, my algorithm is so fast. Okay. Then on the other hand, so parallel programming. Oh yeah, so that's one side of it. The other side of the parallel programming course that may or may not still be offered is it says if I have 10 computers that aren't each so strong, the work that I can do can be shared across all of them and work quite well. So that's 2 different sides of having powerful computers. One thing I did want to mention on that topic as I was talking about it is oh nuts. Okay. Oh yes. So let's say right here I'm like, oh well, I have the OpenStack room at Carleton in Harrisburg. It's big room, has all the stuff. Why can't I just say I want a computer with 1,000 virtual CPUs and 4 terabytes of RAM? And the reason for that is because each virtual machine is placed on one of these computers, not multiple. Once a computer fills up, or once it's close to full, and maybe I want to make a virtual machine on both, you can't do that. And so instead, the virtual machine thinks on the computer level. It's running on one computer, and the software we write on top of that, maybe that says the computers can network together and do smart stuff together. And so the limit, as we saw for most of these servers, is 64 virtual CPUs and a certain amount of RAM. And so you can't go over that. If you were able to say, I'm getting all 464 virtual CPUs on this server because the work I'm doing needs to basically pin the entire core. That means like use all the processing power. You could do that, but you couldn't go to 65 unless like you're saying that each core is doing part of the work that needs to, or whatever. You can't have 65 physical cores on that computer. Okay, so with that, I think that's the end of what I wanted to cover in this overview, and hopefully I can make another one sometime in the near future to go over some other cool stuff about what's being done under the hood on some of these virtual machines.